Problem number 11, it says in the xy plane, the graph of which of the following equations is perpendicular to the graph of the equation below. So now remember that perpendicular lines have inverse and opposite. Slopes. Now what I mean by that is if this is the slope of one line, then the slope of the other line is equal to the negative of the inverse. Okay? So you take and flip the first slope and then tack on the opposite sign, whether it's positive or negative. So what I'm going to do is I'm going to take this and solve it for y equals mx plus b, because we know that the m is our slope. And we'll start from there. So if I say negative 2x plus 3y equals 6. By the way, we're solving for y. So I'm just going to move everything away from y. So I'm going to add 2x to both sides. My x's look like y's. Those cancel. I get 3y is equal to 2x plus 6, because that's a positive 6. Then we divide everything by 3. And I get y is equal to 2/3 x plus 2, right? Because 6 divided by 3 is 2. Here's the slope of the original line, all right? Now I want to find one that is perpendicular to that slope. So my perpendicular slope will be -3, and I'll write it like this, right? You guys know that this symbol means perpendicular, right? So that would be -3 over 2. Now there's a pattern here that emerges. Notice that when it's written in the standard form, that my slope is really the x over the y, right? But it's the opposite because I have to move that x term over to the other side. So this means I should have 3x plus 2y somewhere in my equation, right?
Okay.
But do you guys understand? I'll give you a second to let that process. Raise your hand if you don't see where I'm getting this from. Okay, good. We all see it? All right, cool. It's not this one, not this one, not this one. Hey, here it is. What a coinky-dink.
Oh, what a coincidence.
Hmm?